Alright, then, let's do our notes. So, there are two graphing problems. We're going to do the second one. Okay? We're not going to do the first one. If we have time, we'll come back to it. We're going to do the second graphing problem in our notes today. It has 3 pieces to it. So instead of having 2 like the ones from yesterday, it has 3 pieces. We are still going to break it up and do 1 piece at a time. So I'm going to look at the first part first, that top line. That tells me f of x equals -1 if x is less than or equal to -1. So that tells me if I'm going to graph it, I'm going to have y equals -1 if x is less than or equal to -1, right?
What if it's not?
Then it'll be one of my other options. We'll get to that in a second.
So it's like F and check?
No.
No.
There are different criteria for each part.
Every day.
There's different criteria in each part.
Okay.
Okay, we're just taking this top one first. So the first thing I'm going to do is I'm going to take my endpoint. What is my x value for my endpoint going to be? X equals -1. So that's the first thing I'm going to do. I'm going to let x equal -1. When I do that, I'm going to plug it into the equation. Is there anywhere to plug it in up here?
No.
No, so y is just going to equal -1. So now I'm going to have an endpoint at -1, -1. The real question is, what type of endpoint will it be? Will it be a filled-in endpoint, or will it be an open endpoint? It'll be closed or filled in because it's or equal to. So filled in. So at -1, -1, I'll have a filled-in endpoint. That is part 1 for this. Part 2 then, I need to pick a directional point or an x value that fits this criteria. What is another x that is less than or equal to -1? -2. 0 is greater than -1.
I realize that.
So now I'm going to let x equal
Inner Ethan.
-2. Same thing, I try and plug it in. Can I plug it in anywhere? No. So y is going to equal -1. Does that make sense so far? So at -2, -1 is going to be my directional point then. So -2, -1, I plot my point, I go for my endpoint, and I draw a line through that directional point using a straight edge. From the endpoint through the directional point and keep going. Okay, we all understand that part?
Yes.
Okay, now yesterday, there was only a second piece, and you do the same thing. Today we have 3 pieces here. So our second piece is going to be a little different. So part 2 here, we have y equals 1 if x is between -1 and 1. So instead of just having one endpoint here, what do you notice? We're going to have 2 endpoints. We're not going to need a directional point. We're just going to use -1 and 1 as our 2 points and draw our line in between them. So first thing I'm going to do is I'm going to let x equal -1. I go to plug it in. Is there anywhere to plug it in here?
No, y equals 1.
No, just y equals 1. So at -1, 1
Open circle.
will be an open endpoint. Why is it open? It's not or equal to. So at -1, 1, I have an open circle. Mine's off a little bit, that's all right. Then, instead of picking a directional point, I'm going to use that second endpoint where x is 1. So I'm going to let x equal 1. Same thing, nowhere to plug it in. It's just going to be y equals 1. So at 1, 1, I have another endpoint. Is this going to be a filled in or an open?
Open.
Open again. It's not or equal to. So 1, 1, I have another open.
It's just a
So then, draw a line in between your 2 endpoints. Does that make sense?
So when it's like the 2 signs, like one's a 3.
When it's got multiple pieces here, right? It should be 2 endpoints, yeah? Anytime we have 3 different values, there's going to be one part that's like that.
Always.
Always. Okay, then our third piece, if you look at it. Third piece. We're going to have y equals x if x is greater than 1. So y equals x if x is greater than 1. Now here's another one. I'm going to pick an endpoint And I'm going to pick a directional point.
2.
So first I'm going to do what, Ethan? Let x equal what?
Oh,
1.
1. Good.
Yeah. Shut up.
Take 1. Plug it into your equation. I get y equals 1. Right? I plug it in for x. So 1, 1, I'm going to have an endpoint. What type of endpoint is it?
Open.
Open. It is okay to have 2 endpoints in the same spot. Right? In this case it's 2 open. That's fine. If it's an open and filled in, yeah, it might look like just a filled in. That's fine. I will know that. Or what you could do is you could have one that's filled in and then do an open one around it. Either way is fine.
Yes, sir.
Alright? You can have 2 endpoints at the same spot. That is okay. Then I need to pick one other value of x that fits that criteria.
2.
What is a value of x that is greater than 1?
2.
2. Let's just use 2. Or you could use 3.
Or 4.
Or you could use 4. Or 5. Or 6. Doesn't matter. I'm going to let x equal 2. Well, if x equals 2, I plug it in. Y is going to equal 2. Right? Yes?
Yes,
sir. Yes, sir.
So then at 2, 2, I have my directional point. And then at 2, 2, I put my point. And I go from my endpoint through my directional. And I draw in my line.
With your straight edge.
With your straight edge. That's it. That's all 3 pieces graphed.
You don't have to go like right.
If you have 2 pieces, all you have to do is for 2 of them. Right? Take it step by step. Does that make sense?
Yes, sir.
Oh, that's hard.
Does that help a little bit?
Yes. Yes, sir.
Yeah.
Okay.
That's right, sir.
Alright. The next thing we're talking about is step functions.
Sounds hard.
Step functions look like this. It kind of look like steps, right?
Wow.
Whoa. So, what do we know about filled-in circles and open circles?
The filled in circles are like with the greater than or equal to. And then
Okay, what's the really important piece there? The
or equal.
or equal to, right? If we were talking about on a number line, we said we can include filled-in circles, we cannot include open circles, right?
Yeah.
Same sort of thing if we're looking at these step functions. If I'm looking for f of 6 on a graph, the other day we said we would do what? We'd look where x equals 6, correct?
Yeah.
So if I look where x equals 6, I want to know the y value. Well, x equals 6 at this open circle and at that filled-in circle. Which one do you think is going to be our answer?
Filled in with.
The filled-in one, right? I cannot include the open circle. I can include the filled-in circle, I guess, technically, right? Filled-in circle. Filled-in point. I can't include this first one, but I can include the filled-in one, which would be at 1. Y would equal 1. Okay, f of 2, I'm going to look where x equals 2. I'm going to go down, I have a filled-in point, and I have an open point.
Only concept filled in.
You can only count the filled-in one, so it's going to be at
Negative trace.
-3. Does that make sense?
Yeah.
Right, we can't include those open circles. Are we all writing this down?
Yeah.
Oh wait, like writing like you can't.
Yes. I'm on it.
Over here, if I have f of -1, I'm looking where x equals -1. I go down, I have a filled in and an open. I need to take that filled in part, so that'll give me y is -1. F of 3, so look where x equals 3. I have an open circle and I have a filled in circle. I gotta take that filled in one. 3. Okay? Okay, does that make sense?
Yes.
A little bit.
Do we have any questions on that? Okay, then we have 2 more problems we're going to talk about.
Okay, yep.
Writing piecewise functions off the graph. So what's going to happen is they might give you a graph like this, and it might be like, hey, write your piecewise function. The first step is to name your function, right? You can use f of x, you can use g of x, you can use whatever you want. I use f of x most of the time. So f of x equals, a nice little squiggly line. I don't know what that's actually called.
It's called
It's probably got a real name, but I don't know what it is. Ethan, you don't know.
a boundary.
Okay. How many pieces should I have to this piecewise function? 2. Right? I have 2 pieces on my graph, which means I should have 2 pieces to my piecewise. There's 2 different ways you can go about this. The first way I'm going to show you is the way that I always do it, and then I'll mention a second way. Alright? The first way, if I'm going to look at this first piece,
Another point.
I need what to write an equation?
2 point.
I need slope, and I need either a
Y-Intercept.
point or a y-intercept. I'm going to go with point and slope.
Okay.
So, the first one, I'm looking at the one on the left. What is my slope? I go up 1, over 1. Up 1, over 1.
1.
1 over 1 or just 1, right? Now I want to find the y-intercept. Is that actually showing on my graph?
No, it's
No, but you
not.
can,
No.
you can figure it out.
But we can figure it out, right? Pretend it's going to keep going, right? Up 1 over
It'll be
1,
fine.
up 1 over 1. That would be my y-intercept right there.
I can't count that high.
It'd be at 1, 2, 3, 4, 5. So my equation would be y equals 1x
Plus 5.
plus 5. So in my piecewise function, that first part is going to be that right side of my equation. You can either write 1x plus 5 or just x plus 5. So that's the first piece of the first part.
Then write a comma.
Then I always put a comma, you don't have to. We need to figure out what x values are we using that for. Well, if I look here,
X.
at what x value does it begin?
-2.
Negative 2.
Is
Is it go less than negative 2 or greater than?
less than.
Less than. So x less than negative 2. And then look, is it an open circle or filled in? Open. So should I have or equals to?
No,
sir.
sir.
Okay. That first part's all done.
Easy.
The second part, the one on the right, same thing. I'm going to find the slope. I'm going to find the y-intercept. Well, the slope for my second one. Find 2 points. It goes down 1, 2, to the right 1. So it's going to be
2x.
negative 2 over 1 or just negative 2. Does it give us a y-intercept?
Yes.
Yes.
Yeah, at negative 2. So I get y equals negative 2x minus 2.
Okay, then what?
So if I go to put that in my piecewise, I'm going to write negative 2x minus 2, comma, I'm going to figure out, well, what x values do we use that for? Well, where does it start? At x equals negative 2, and does it go less than or greater than? Greater than. So x is greater than negative 2,
I don't think that works.
and or equal to, because it's a filled in. Greater than or equal to. That's not greater than negative 2.
There you go.
Okay. And that's it. That's the whole piecewise there. That's your answer. You do not put a bracket to finish it off. There's no bracket on the other side. Right? Because then it's kind of closed. We don't want it closed. Are there any questions on that? Time we out of here.
We should be done.
12. Ooh, so in 2 minutes.
Yay.
Okay. We're not going to do the second one. We can go through the second one tomorrow in class if you'd like. Are there any questions right now?
Probably.
Please ask a question if you have it.
Not at all. You were asleep
What's
for
your
whole
slope
lesson.
Yes. Yes.
Wait, were you recording?
I was recording.
Good luck, Charlie.
Subscribe, swipe up.
Good luck, Charlie.
Control that.